right. Okay, I hope you can see this. We start. What of crystallization? When crystals of certain salts are formed, all right, they do so with a definite number of water molecules. All right, so crystallization is is the ability of a substance to form crystals. All right, to form some kind of crystals like that. For a substance or for a salt, what is a salt? A salt, it's a substance where you've got your ionic compound. It's an ionic compound where you have got a metal and a non-metal. All right. So you've got water of crystallization. This water is chemically bonded in a definite proportion. So there's a certain number of moles of those water molecules that enable a salt to form, to crystallize, that enables them to crystallize. Please just open the screen there and the windows a bit. Open the windows a bit for circulation of air. Right. The water of crystallization is the number of water molecules chemically bonded with the salt in its crystalline state. So please copy that. Copy that second statement here. The water of crystallization is the number of molecules chemically bonded, chemically combined with the salt in its crystalline state. In its crystalline state. In its crystalline state. Water of crystallization is the number of water molecules chemically combined with the salt in its crystalline state. In its crystalline state, yes. I'm gonna zoom it more. Does that make a difference? Okay. The water of crystallization is the number of water molecules chemically combined with the salt in its crystalline state. All right, we move on. All right, this water is responsible for the geometric shape and the color of the crystal. So what does that water of crystallization give these water molecules? It makes them to be able to form crystals, all right, which have got a certain geometrical shape. So if you look at the crystals, they're going to be looking like with a certain shape that they will have. And also the color of the crystals changes, like copper sulfate. Copper sulfate, if it is water of crystallization, actually the color is blue. When you take away the water, then it becomes white. So it comes with the color. So this water of crystallization gives geometrical shapes to the salt, and it also gives the color to those particular salts. Clear? Right. Example here. You've got your copper sulfate. All right. Anhydrous. When something is anhydrous, it means it doesn't have water. Hydrated, water of crystallization. Hydrated means it will be having water. So the picture we get when we think of copper sulfate is royal blue crystals. In fact, this is just one form. This is the hydrated form. The hydrated form means it contains water. All right. The one that is no water, it becomes anhydrous. Anhydrous means no water, right? And the color as well is going to be different. It's going to be white. All right. So this one here, the blue one that you have here, that's your hydrated one. That's the hydrous copper sulfate. And the white here, that becomes the anhydrous. So the difference is water. When you add water to the white one, it becomes blue. When you evaporate or when you heat this blue one, the water is going to evaporate, then it becomes white. So they interchange between these two forms because of either the addition of water or the removal of water. How do you remove water? You have to heat it so that you evaporate the water. Clear? Right. Next one. The water of crystallization is the fixed number of water molecules. You don't have to write this. All right. Water of crystallization is the fixed number of water molecules present in one formula unit of a salt. So examples here. I hope it's clear. It's a bit not exactly clear here. You've got your copper sulfate, CuSO4. So you can just write example, e.g. You've got CuSO4, 5H2O. Can you see this? CuSO4 dot 5H2O. CuSO4 dot 5H2O. That 5 mole of water there, that's the water of crystallization that we're talking about. So far, we've just been talking about copper sulfate here. All right, but now we're adding dot 5H2O. That's the hydrated part. That's the water of crystallization. That's the water that enables copper to form crystals and change color. That's the. Then another one is sodium carbonate, which is Na2CO3 dot 10H2O. Na2CO3 dot H2O. 10H2O, sorry. Na2CO3 dot 10H2O. Then the last example, that's calcium sulfate. CaSO4 dot 2H2O. Those are just examples, just to name but a few. So there's more of this, but we're just highlighting these ones here. All right. So in our calculations, you're going to be asked to calculate those number of moles, that the number of moles of that particular water. So we're going to look at that. Right, so we're going to look at an example. This example here, you'll be asked to calculate the number of moles of water of crystallization. How do you do that? Let's have a look here. Right, so let's look at this example. Aluminum trichloride, which is AlCl3, is an ionic substance that forms crystals in the solid phase. Water molecules may be trapped inside the crystal lattice. We represent this as AlCl3.NH2O, all right, where N is the number of moles of that water of crystallization. Karin heated some aluminum trichloride crystals until all the water had evaporated and found that the mass after heating was 2.8 grams. The mass before heating was 5 grams. So there are two answers that we have, two numbers that we have. We've got 5 grams where we've got aluminum chloride plus the water of crystallization. Then after heating, all the water evaporated, only what remained was aluminum chloride, which is 2.8 grams. What is the number of water molecules in the aluminum trichloride before heating? That's what we need to calculate. How are you going to go on about that? We're going to do the following. Step number one, find the number of water molecules, all right? Find the number of water molecules. First, we need to find the number of moles, all right? The number of water molecules that are present in the crystal. To do this, we first note that the mass of water lost. So we're going to subtract the two answers here, the two numbers that we have above here. We've got initial mass, which is 5, including the water of crystallization. And we've got 2.8 grams, which is the mass of just the salt without the water. So we subtract the two to see what was the mass of the water that evaporated. So what are we going to do? We're going to subtract 5 minus 2.8 to give you 2.2 grams. So the water that evaporated, its mass is 2,2 grams. Are you following? Right, we'll move on to the next one. Find the mass ratio. You need to find the mass ratio, right? So what are you going to do? The 2,8 that remained, that was the mass for the salt. And the 2,2 was the mass of the water. So you'd write it as a ratio. Next one, right? To work out the mole ratio, we need we divide by the mass ratio, just like what we did on the empirical formula yesterday or the day before yesterday, which was, I think Friday, we did the empirical formula, all right? So what are you going to do? You're going to divide mass over molar mass. So from your ratio, you've got 2,8 grams aluminum chloride. Then you've got water, which is 2,2 grams. I hope you understand where these values are coming from, right? Then you move on. You're doing number of moles is equal to mass over molar mass. So we're going to divide. What do we divide? We're going to divide 2,8 divided by the mass of aluminum chloride. Aluminium, if you check on the periodic table, I think it's 24, right? Then is it 24 aluminium? I think it's 24. Then aluminium chloride is 35,5. You multiply it by 3. So 35,5 multiplied by 3 is going to give you 100 something. Then you add plus 24. Your total answer comes to 133,35 grams per mole. Then you divide the 2. 2,8 divided by 133,35. Your answer becomes 0,02099. Then you do the same for water. What is your water? Your water is the mass that we found that evaporated was 2,2. Divide by the molar mass of water. How do you find the molar mass for water? Hydrogen is 1 times 2, which gives you 2, because there are 2 hydrogens, plus oxygen, which is 16. 2 plus 16 gives you 18. That's where that 18 is coming from. You divide 2,2 by the 18, your answer becomes 0,12. You just make sure your number of your decimal places are the same. The first one had 5 decimal places. This one must also have 5 decimal places. But it ends, if it just was 0, it comes out 0,12, then it's fine. You leave it like that. But if the numbers are still continuing, you also need to keep the same number of decimal places for the 2 answers or 3 answers, depending how many answers you're going to be having. Right, next we convert the mole ratio to whole numbers. So now, just like what we did for empirical formula, you look at the one that is the smallest. You look at the one that is the smallest. Then you divide with the smallest. Clear? All right, so you must be careful here. Which one is the smallest here? Is it 0,112, 0,12, or 0,02099? Which one is the smallest? 0,12. Right, that's wrong. The answer, the smallest one, you must look here. Actually, if I make the same number of decimal places, how many decimal places do I have here? I've got 5. Here I've got 2. So I'm going to add zeros here. I'm going to add a 0, add another 0, add another 0. All right, I'm just going to ignore the comma, and I look at this number. This number is 2099. If I just look at this number here, it's 2099. Do you see that? When I look at this one here, it's 12,000. So which one is bigger? Is it 2099 or 12,000? 12,000 is bigger. So which one is the smallest? The smallest is the first one, your 0,02099. Please be careful with decimals. Be careful with decimals. Same applies if I've got a number like this, 0,09. I've got 0,09. And another number is 0,1. Which one of the two is bigger? Which one is the biggest here? 0,1. Because I'm going to do 2 decimal places here. I add a 0. Then I can compare. This is actually like a 10. This is a 9. You see that? So please be careful wherever you have decimal places. Right, fine. So here 0.02 is the smallest, so we're going to divide by the smallest, which is 0.021. You divide it by 0.21, then your answer comes out as 1:6. All right. Your answer might not come a straight whole number. You need to round it off after dividing by this. Clear? You need to round it off. But if you normally get a comma 5, like the homework that I gave you, there was a comma 5 there. If you get a comma 5, then you have to double it. The comma 5 must be multiplied by a 2, only when it's a comma 5. Then the rest you can always round off. Or let's say you get a 0.25. You know 0.25, I can multiply it by 4 to become a whole number. So you need to also to apply that. Clear? All right. It's only numbers that are not definite. They don't have a definite number to multiply with for us to get a whole number. Right? Those are the ones that you're going to be rounding off. But straight numbers where you can just double to get a whole number, you need to double that. Okay. So here you get your 1:6. Right? So it means 1 salt to 6 moles of water. So 1 mole of salt needs 6 moles of water. So the ratio there becomes 1:6. Now you go and write your final answer. You go write your final answer. Right? Your final answer is going to be, remember the N was here in front of the water. So the final formula now becomes aluminum trichloride, and you've got 6 moles of water. 6 moles of water. Is that clear? So the N in that beginning of the question there, that represents 6 moles. N represents 6 moles. So basically, this is what you're doing. The question on the water of crystallization, you're going to be asked to calculate, to determine that that N, the number of moles of water of crystallization. All right, I stop here for questions. Any questions so far? Any questions so far? Okay, if there are no questions, I move on to the second example. Can I just check people online? There's someone with a, who's a WDK with this funny number here? Your name, please. Must unmute. Hello, your name, please. WDK.
Gamelisha, sir. Gamelisha, sir.
Who? Gamelisha.
Yes, sir.
Okay, Gamelisha. By the door. All right. All right. And how far are you with your work?
I'm up to date.
Up to date. Okay. All right. So you please next time just write your name here so that we see, because we tend to mark a register to check who's following, who's not. Ne?
Yes, sir.
Just write your name when you log on so that we don't call you WDK. Ne?
Yes, sir.
Okay, thank you. Right. Let's move on. Right, I only have one example here. Okay, I think you guys, you fine with this. Okay, let me give you time to do number 1. So if you haven't done your homework, I don't know how you're gonna do. I wanted you to try number 1 so that I see if you're following what I'm saying. But you can do this exercise now. Can you? You can now, right? Okay, so you guys, can you write today's date and do this classwork here? Let's do this classwork. All right, please, if you didn't do yesterday's exercise, which was exercise 30, you might need to start with that, or you leave space, all right, for that. Then you do this one, then you go back and do the exercise 30. Tomorrow we're gonna revise, we're gonna have to revise both of them. All right, exercise 30 and exercise 31. All right, so what I'm going to do for people at home, I would like you to do number 1 for now. Do number 1 so that I check whether you're on track. Then after that, I'm going to post this on Google Classroom, and everyone is going to log on onto Google Classroom. Then you work from there. Is that fine? Is that fine? All right, okay. So you guys, let me give you how many minutes? Let me give you about 6 minutes. to do number one? Can you do number one at home as well? Do question number one. Yes. Come again. I'm lost. What do you say? Oh, I must do number one, then I must work it out. Yeah. Or plus the example. So I need to scroll like down or up. You want like this? Or you want to take this? But it's kind of long this one. I don't understand what you're saying. You say you want this. You want this to take a picture, or so that you can work from there. Okay, all right, I get you now. So do you need the question here, or you just need the steps? Steps. Okay, there are the steps. There are the steps there. Are you fine? Can I scroll down? Okay. You took that part, then you can take a picture of that. Okay, then the last part. This is the last part. This is the last part. All right, then I can project. All right, then I can project the question. Right, then can you please do number one? Do number one. I give you 6 minutes. 6 minutes. Let's start.
Sir,
Yes.
may you please go back to step 3? My phone disconnected, so I couldn't take a screenshot.
You didn't take the picture. Okay.
Yeah, I couldn't. My phone was having network issues.
Okay. Just a sec. Let me put my charger. I'm gonna post this on the classroom now.
Okay, sir.
Yeah, but you can take a picture so long. Let me just scroll up. Yeah, so the example starts here. You can take that.
Yes, sir.
In the solution.
Yes, sir. Yes, sir. Thank you, sir.
And then there's the last part there. The final representation of the solution. That's what you have here. Okay. Yes. Yeah. Step 3. Yeah, it's not the final. Is it before you choose the thing? Before you choose the lowest, choose which one is the lowest. Yeah, just make it 4 or 3 decimal places. Don't make it too long. Yeah. Are you guys? If you get cut off, then you're gonna have to rejoin, right? So that we do the corrections for this. The ones who are online. Yes. Huh? Where do I get the? Okay, let me just go to that example. Step 3. Where do I get 133 from the periodic table? So I'm gonna take for the salt this. I need the molar mass for this on the periodic table. Then the 18 is the molar mass for water. Remember, you are doing a ratio of AlCl3, that's your salt and your water. So you must look for the molar mass for the water. Yes, must go up. Do you? What do you mean times? No, you add. You add. It's aluminium, it's 1. So aluminium is 1, so it's going to be, what is the molar mass for aluminium? It's 24. Then you go to chlorine. Chlorine is 35,5, but how many are they? They are 3, so you multiply by 3. Because it's more than 1, yes, you multiply by 3. Are you answered? But you are adding the masses of the different elements. Where they are more than 2, you have to double it or triple it. Yes. Like Cl, it's 3. So I'm going to say, actually, I'm supposed to say 35,5 plus 35,5 plus 35,5. So I just say 35,5 times 3. Are you answered? Okay. So there's addition and multiplication in between. Yeah. Okay, less than 1 minute, we're going to be disconnected. You guys, you have to rejoin. Last time you didn't rejoin. People online, who was this? Gamelise, Joshua, and Dempo. You have to rejoin after we are cut off now. You want the person? Are you done?